Hey.
Hey. I wore this shirt today. It says best day ever. It says together we are so super. That's how you choose makes me
Okay.
feel. Yeah.
That sounds like something you have from the high school days.
Yeah, it's I feel it today. But what something do you remember when we made like a 6-minute video to promote the fact that we're about to start a security series of You Choose? Do you remember we did
Yes,
that? Yeah.
I
And
do. I
then
do.
going into You Choose, I know nothing about anything that we're about to cover, and I'm learning it all on the fly. And one thing you told me back then is that people don't like security, is what you told me. That it's unpopular, and people don't like it. Do you remember?
I mean, people who are not in it. Yes.
Yes, people who are not in it.
Mm,
And
yes.
I'm, doe-eyed and like, what? Why not? Why don't they like security? And do you remember what you said?
I don't. Now you're asking too much.
Because they're because they're just told that there are thousands and thousands of vulnerabilities. Like they want to deploy their thing and they can't do it because there are 6,742 vulnerabilities. And so
They're depressed.
what's that?
They get depressed.
They get
No,
to
nobody likes to hear bad news, right?
I bring it up now because we are on the Kubernetes scanning the episode of You Choose. And so we're finally going to learn about these vulnerabilities that we talked about so long ago. And I'm pretty psyched to dig into it.
Yeah.
But before we do, our first order of business is to talk about our journey so far, where we've come from, and say hello, everyone. Thanks for everyone who's waving in the chat. Please do say hi and where you're from. It's so cool that you're here. So we've gone through a lot of things. We've done admission controller policies. We've talked about runtime policies. We talked about secret management, and then last week we talked about mutual TLS and network policies. I'm
Excellent.
learning that security has a lot to do with policies. Saying giving permission to saying what's allowed to happen so you can say everything else is not allowed to happen.
What's allowed to happen? Who can do something? And things like that. Yes.
Yeah. So last week MTLS was network policy and it was a pretty juicy one because it was all the service mesh options in the CNCF landscape. So we
Yeah.
covered
People chose in that area. People chose to put random now infinite number of projects into CNCF, right?
in service mesh in particular. What do
Yeah,
you mean?
exactly. I mean,
Yeah.
service mesh networking. It's
There's a
there's
lot.
a lot of those. Yeah.
Yeah, it's a lot. And it's a lot to learn if you're not like kind of from scratch too. It's been a lot to go from zero to understanding on making a big assumption that I've reached understanding. So we talked about the 5 technologies we covered last week, or Linkerd, network service mesh, Cilium, Kuma, and Istio. And so let's recap those 5 technologies in MTLS. So before we kind of talked about, we wanted to cover them from a security standpoint as opposed to the fact that they can all do networking and observability too, right?
Yeah, I mean there
Security
are
and
many other
networking.
things that they do, and we will be coming back to them or some of them uh, later on. Like, I mean, the next set of streams we'll do after security is going to be observability, and then we're definitely going to bring them back.
Excellent. That'll be fun. And so from an MTLS standpoint, at least, only one of them actually implements network policy, I believe, if memory serves, and that's Cilium. Um,
Uh,
but
I mean, they all have network policies, or at least
yes.
Cilium, Linkerd, and Istio for sure, and others probably as well, right? They all have network policies on different levels.
So when I said network policy, I meant like the Kubernetes network policy object. And I think when you say they
Ah,
do network policy, you just mean that you can create policies about what's allowed to talk to what other thing. So
exactly.
yeah.
That's because the network Kubernetes network policy, the spec that is baked into Kubernetes, right? that's related to CNIs, and only CNC is a CNI, and Cilium operates at that level, right? Now, others are on a higher level above CNI, and they also
Okay.
have network policies, just not those network policies, right?
Just at the application communication layer, as opposed to like what's even connected to what else layer. Yeah. That's the official term. Yeah. So let's play our game where we say one sentence for each technology that was on. Okay. So Linkerd.
Second iteration, completely rewritten. Good thing. Relatively, probably the easiest. Okay, here's one sentence. The easiest one to use.
Yes, and that's like their tag. That's like what they want you to know too. The easiest to implement.
It's not that others came a long way. So it's not that Istio is nowhere near as complicated as it was in early days. So it's not that others are not easy. It's just that this one might be slightly easier.
And it's I understand it's lighter weight too, since it doesn't use Envoy as a proxy. Instead, it has its own handwritten REST proxy. But yeah,
I mean, it has its own proxy. Now we can discuss in a length, kind of like how lighter this is than Envoy and things like that. But yeah,
you're right.
Let's put it this way: it's the only one that doesn't use Envoy.
Yes, the only one of the sidecar versions that doesn't use Envoy. Yes.
Yeah, exactly.
And then, so Istio then.
Same as Linkerd, just slightly different.
Great, I understand. Perfectly illuminated.
There you go. Now you know everything you should know about it.
A little more complex to use, but more fully featured. Probably a little heavier weights, maybe a lot heavier weight depending on what you're doing, but more fully featured. That comes with that extra complexity, right?
Exactly.
Which is a trade-off I've seen a few times in a few different texts, right? And then we have Kuma's the other one that uses sidecars.
Yeah, I know nothing about it, so my explanation of it is it's a service mesh. It's same like other two, but slightly different.
Kuma's good if you want to do multi-cluster. It's like it's designed for multi-cluster and not just multi-cluster, but multi-environment, because it runs as an operating service process too. So you can incorporate VMs and even physical machines into your mesh with your Kubernetes environments.
The way I like to describe, and I'm now describing all of them, except for Cilium, is that they're all having more or less the same features. It's more a question of where are they focused more.
Right.
Kuma starts with the main focus is multi-cluster, right? But it still does the rest of the things that most of the others do, right? And Linkerd also does the same things that others are doing. I mean, when I say the same, but it's literally the same. So interpret my words. But focuses on simplicity, right? And potentially speed. And these still, we do also the same things that others are doing, but we are focused on giving you extra things that nobody else thought of, right? Kind of like we have more features than anybody else. But the important ones are covered in all of those. Now people are going to hate me for that, but that's why I said
I think you're right.
It's the same, but slightly different, right?
And I'm under the impression is when everything was being created, there was a lot more differentiation between the projects. But as they each grow and someone who's already implemented one wants some of the features of the other, they just add it to one. So they kind of all are growing in a way that makes them overlap a lot more than maybe they used to. Also,
that's what happens.
Is that accurate?
Yes, that's a sign of maturity, right?
Yeah.
In early days, you have different projects that are tackling different problems or from different angles, but eventually, if that thing becomes a thing, it becomes widely adopted as service meshes, they eventually converge on the same set of features, right? That does not mean that they're working behind the scenes in the same way. That does not mean that they're using the same syntax to describe things, but feature-wise, it's like Cold War, right? Yeah, whomever figured out some better way to do missiles or whatever, the other side gets it soon after, right?
I wonder if there's espionage within the service mesh projects.
It's open source. Everybody
Go
knows
contribute over there for a while, see what they're doing. It is all open to the public, yeah. My favorite moment of the episode last week was when we asked Marino like how well Istio does with multi-cluster.
It's well documented.
He said it's very well documented. That's very funny. And so then we have the two that are not sidecars that we haven't mentioned yet. We're doing a terrible job at the one sentence thing. And the first one is network service mesh. And so network service mesh is you have a network service that can run anywhere. It doesn't have to run in your cluster or even within. But the workloads, first of all, this is happening at level 3 instead of up at level. So we're connecting IP. It's doing an IP packet level, and then the workloads can all connect to the network service, regardless of where the workloads are running. So basically, you can have multi-cluster, or again, it doesn't matter. It could be running on VMs or bare metal. It could be running in a whole different company. And you have a way for these workloads only to connect without having to go through a gateway. So it's pretty cool tech, but it's kind of different than everything else. And then the last one is Cilium.
Yeah, it's a multi-cluster. Again, the same, but yet somehow different.
But your work, instead of connecting entire clusters to each other, you're connecting just specific workloads from
That's
each
true.
place to
That's
each
true.
other. Yeah. And then Cilium's the last one.
Yeah, Cilium is a different thing in terms of...
Yeah.
Yeah, but yet the same. Cilium is a CNI, right? First and foremost. And then service mesh is something that was added later, and then they're still working on it, right?
So CNI, for the uninitiated like me, is a container network interface. And so it's what the kubelet uses. Yeah, it gives the network stack to the kubelet.
Think of it as low-level Kubernetes networking, which is not optional. Okay,
Yes.
that's not optional. You need to have CNI implementation, one or the other, in your Kubernetes cluster, no matter whether you choose to use service mesh or not, right? Service mesh is optional. We heard last week that according to people in those projects, it shouldn't be, but it is. So Cilium is special in terms that you're most likely running Cilium no matter what you use for service mesh. Right? So I'm not saying that 100% of Kubernetes clusters is using Cilium as CNI, but significant percentage of the clusters is using CNI, right? And then to me, the real question is, when you go above that layer into service mesh, do you stick with Cilium or you go for Istio, Linkerd, Kuma, network service mesh, right? Now, as a service mesh solution, now this is the only one that I cannot say, it has all the same features, things, right? It's not there yet.
Yeah.
Which does not necessarily mean that you need the things that are missing, right? But if you compare it only as a service mesh and not as everything it is, then it's slightly behind. That's not necessarily a bad thing, though.
It might have everything you need, even though it doesn't have everything.
Yes, and it's already there.
Yes. Yeah. Cool. Do you think it's time to reveal our winner?
There we go.
I guess so. Cilium. All right.
Yeah.
Do you know, I was the one person who voted for network service mesh because I really wanted to see it. That's me.
One vote. Honestly, it's very dark. Yeah. Okay. You need to do better next time with me.
All right.
Let's people.
Let's show us. Let's implement it. Cilium.
Okay. You see my screen? All good?
Marino's here. Marino, we were talking about you. Marino said, is it bad that I voted for Cilium too? Marino represented Istio last week. So what I want to say, Victor, this week is different your background's different. You're clearly in a different place, and also your terminal's different in that you have some commands on the left I can see. Will you explain?
Yeah, exactly. I'm cheating here. I'm using the repo that contains all the commands and everything for all the projects anyway, or most of them. So I'm cheating today.
But
for a couple of reasons. First reason that I'm cheating is because now I'm traveling, so I don't have a second monitor, so that you don't see that I'm cheating.
So that's what I was going to say. You do this every week. You use this repo every week and during our live demos, but you just can't see it right now. You can see it now when you couldn't see it in the past.
Multiple monitors, then it looks like I know all those things by heart. It makes me look clever, which I'm not. So
excellent. Okay.
So here's a definition of a couple, two applications. Let's say silly applications, right? I'm going to run a pod called sleep. You can guess what it does. It sleeps for infinite amount of time. And not infinite, but long amount of time, and one HTTP bin, which is a pod that contains HTTP binary that we'll use later, right? So just two applications, nothing really special. I'm using them to demonstrate what I'm going to show soon. So kubectl namespace product. And I'm going to apply file name as Cilium MTLS, right? By the way, Cilium is installed in this cluster long before we got to this section, right? The clusters we've been creating all have Cilium and CNI, right? What I did in advance now for this episode is that I updated the Helm chart in a cluster to add Spire, which provides MTLS for Cilium, right? So if I do kubectl namespace production get Cilium and points, you can see that here are the endpoints of the stuff that is happening in my cluster in the production namespace, right? I have my application, 3 pods. I have what is this? This is Schema Hero and HTTP bin and sleep that I just applied, right? Now, what I'm going to do is get identity of one of those. There we go. Oh, and that one is actually the sleep, pod. And I'm going to execute into the Spire server and show how Cilium sees that. And you can see this is the identity that Cilium established for the sleep pod that I created a moment ago, right? And you can also see that I'm going to copy and paste instead of typing this one, that if I go back to the Spire server, so this is all Spire, right? You can see Cilium being now plugged into Spire, which provides the identity for the workloads in my cluster, right? So Cilium itself is using Spire behind the scenes, which I believe we're going to explore in one of the upcoming episodes, right? And if you look at Cilium identities, we can see also this is a Cilium CRD. I'm invoking the CR. We can see that it established identities for everything essentially in my cluster. Now, so identities, MTLS, all that is covered with this setup. Yes.
So it's worth saying that Cilium does not have a sidecar model like the Kuma and Linkerd and Istio. Instead, it's establishing these identities for workloads as they're created, and then it's watching these identities at the kernel level. And that's how it's doing its observability, as opposed to doing it with sidecars and proxies, the way that the traditionally service mesh has been in the past.
Correct. eBPF, baby.
eBPF, baby.
So what I'm going to do next is that I'm going to enter into the sleep container, right? And I'm going to add CURL into it so that I'm going to try from that container. Actually, I just added CURL for now. But I'm going to try to see if I can communicate from that container to some other container, right? That's why I installed CURL, just that I can when I get back to that container, that I can send requests and simulate traffic between applications, right? Now, before I simulate any traffic, here is a policy that I'm going to implement, right? It's a Cilium network policy, and it says whenever the endpoint has the label name CNCF demo, right? Some other container, allow incoming traffic from another endpoint from sleep. In other words, I will allow traffic only from the sleep container in that namespace to the CNCF demo container, right? Pod. So that's the only allowed traffic that I will have to this application, right? Ignoring everything else I have in my cluster. So I'm going to apply that policy, and I'm going to go back now to the sleep container. Remember, I allowed traffic from the sleep container, sleep pod, to the CNCF. And if I go back there and send a request, right, to CNCF demo, you can see that I got, this is Cili demo 200. It works, right? I could send a request from one to another because policy allows that. Now, what I'm going to do next is that I'm going to I'm going to create the same containers that I created a moment ago in a different namespace, in default namespace, right? So remember, I created a policy that allows communication from sleep to CNCF demo within the production namespace. And if I go and try to execute the same, actually, first I'm going to add CURL to that container. Cool. And if I send the same request that I sent before, but not from the production namespace, from the default namespace, it should say, Victor, you're an idiot. You're not allowed to do that. And it will not say that right away for two reasons. First of all, because it's not nice to say that Victor is an idiot. Second reason, because...
You just think it. You don't say it.
Exactly, but it's dishonest. The second reason is that now it is trying desperately to send a request to CNCF demo in the production namespace from the default namespace, which violates the policy that I said, and it will continue trying to do that until it times out. The fact that there is no response means that it's being prevented, and it will continue for a while longer, and then it will time out. And that means that you saw the policy in action. I chose what I allow, and everything else is can be translated to bug off. You cannot do that. You cannot talk to me. Not allowed.
Perfect. Amazing. Cilium. Da 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 da.
Here we go.
Great. I see already we have a question about scanning. And so thank you so much for sending the question. We have a question part of the episode. At the end of the episode, we're going to get to all the questions. So please do feel free to ask any question as you have it. We see your questions, but we're going to get to them at the end.
The important thing is that to ask questions first come, first served.
It's true. We've been running out of time for questions lately. So if you get them in early, they're more likely to get answered. So that brings us to the next part of our show. Our next system design decision is Kubernetes scanning. So what is Kubernetes scanning, Victor? You're muted.
I need to unmute myself. I was destroying the cluster that I created for them.
Very responsible.
What is Kubernetes scanning? I mean, scanning in general means, okay, scan this thing, whatever that thing is. It can be many different things that we scan. And tell me what you think about it. Do you like it? Do you not like it? That's my interpretation.
Nice.
Really. It's about security, really, vulnerabilities, finding out what are the things that are wrong, right? That shouldn't be as they are. That's my interpretation of it. Right? It's not always security vulnerability. It's not always finding vulnerabilities, right? Sometimes scanning will find, okay, so this is not a vulnerability, but hey, you shouldn't be doing that.
Oh, I have questions. First of all, is this required?
What, to scan? Yeah.
Is it? Yeah.
No, only death is required.
Only death is required. If you want to have if you want to be safe, is it necessary to do some sort of scanning?
It's not required, but it would be silly not to have scanning of some sorts of or another, right?
Okay.
And
then
I think it falls into a similar thing like what we spoke before about service meshes, right? Is it required? No. Should you have it? Yes, right? I think that it falls into a similar category.
And then, okay, so then what exactly is being scanned? Are we talking container images?
Anything can be scanned, right? Your source code of your applications can be scanned. Container images can be scanned. Account of your cloud provider can be scanned. Kubernetes workloads can be scanned. Virtual machines below those workloads can be scanned. Anything can be scanned.
Is it dangerous to give your scanner that kind of access to everything?
It's dangerous to maybe dangerous to give anything access to anything, right?
Yeah, that's true.
Like if you go back to the previous episode, I could say that potentially dangerous to give Cilium access to your host
to your
through
freaking
EBPF.
the kernel
EBPF is sandbox, but nobody says that you cannot do some nasty things, right? So there.
So you give a lot of access so that you get security in exchange. Maybe that's something they'll address, or we could talk about later during the question part. So we can scan anything, and then what are we looking for when we scan?
Vulnerabilities, and first, at least in my case, first and foremost, vulnerabilities and not good practices.
Okay. One thing I learned when I was researching some of this stuff is I didn't know there's like a national vulnerability database that like that there's a big source of truth when it comes to all the vulnerabilities out there. I thought that was interesting.
More than one.
Oh, great. Of course, nothing's that
there
easy.
There are different databases, which we'll probably hear about soon,
Yeah. So CVE stands for Common Vulnerabilities and Exposures. And that's when I hear scanning, that's what I think of is scanning for vulnerabilities. And specifically, I guess I think of scanning images for vulnerabilities. But it's important to scan running workloads too, because vulnerabilities...
You can say, okay, I have no vulnerabilities in my images, yet my cluster is completely accessible to anybody in the world, right?
Yeah. Because why?
Because, for example, you happen to open the ports freely.
Right?
What I'm trying to say is that
I see.
It's not always image, right?
Another thing about scanning for vulnerabilities, at least like vulnerability, that those source of truth databases are always getting updated with new vulnerabilities. So you have to scan often to make sure like it's always up to date to the latest security knowledge, as opposed to other kinds of scanning, like scanning configuration that's unlikely to change. Is there anything else we should be keeping in mind, do you think, when we evaluate these technologies?
I mean, I see them as twofold. There is detection, and there is some kind of help. What do I do with it, right?
Yeah.
So one thing is to tell you, hey, you have this thing that you shouldn't have. And another thing is to say, yeah, now you can do this and that to remediate that, right? I'm going to show you docs, or I'm going to show you some output, or I'm going to create a pull request for you, or I'm going to do this and that, right? So it's kind of awareness and fix.
I'll add a third step to that, which is first awareness. Second, filter out the ones that don't matter. Like, because it seems to be like of all the vulnerabilities that are found, the majority you don't need to do anything with. And then tell me what doesn't matter, what does matter. And then of the stuff that does matter, either fix it for me or tell me how to fix it.
Yeah, that's going back to my about being depressed with thousands, right? If I can be depressed with 100, that sounds better, right?
It does. It's kind of nice in terms of just your mood to know 1,000 were there and that you only have to deal with 100, as opposed to 100 coming up and you never knew about the ones you didn't have to think about. All right. I think, is it time to introduce our guests?
Yes, let's bring them in.
Wonderful. First, we have Jamie Smith. Jamie, welcome. Thank you so much for being here. Will you tell us about yourself, please?
Sure. Thanks for having me. I work for Snyk. I'm part of the product marketing team. Of course, as soon as we unmuted is when all the dogs went nuts. So I've actually been around the block. I've been in many aspects of software development, from engineering, pre-sales, part organization, and finally landed in product marketing. So I've kind of seen the world from many different angles. So I'm excited to be here.
Awesome. Thanks. We look forward to hearing about Snyk later. Bye. Next, we have Oshrat. Hello. Welcome. Tell us about yourself, please.
My name is Oshrat Nir. Thanks for having me today. I am developer advocate for Armo and Kubescape. Been in cloud native for 6 years now, I think, sort of around. And I've been in IT for so many years that it'll tell you how old I am, so I'll just shut up. Yeah, and I look forward to presenting Kubescape to you guys.
Awesome. Can't wait. Thank you. Cool. Well, since Victor's in Hawaii, I'm the timekeeper today, so I'm going to get this ready. And then, and I think that's about it. We're going to hear about Snyk first. Hello, Jamie. All right. As soon as you start talking, I'll start your time. I'll put your, there you go.
Perfect. All right. So you guys both brought up a couple points that I'm going to kind of try to touch on here. One of the things that Snyk really prides itself on is the ability to help developers not only find those vulnerabilities, but figure out which to fix and how to fix them. And of course, I got to be on the right app to move it. First thing I want to take a look at is a little bit of that, what you mentioned earlier, of how do I know which to fix. So like when you've got something running, this is the Snyk interface. This is a screenshot. This is like showing a pod running. And we can see, like, so you get some context from the way it's running. It's not privileged, so that's a pass. But it's not set up with CPU limits or memory limits. And those things are things that really get taken into consideration when you're trying to figure out, what do I need to fix first? Is this even applicable to me? In this case, it's not just a CVSS score that we have. We're actually taking into consideration the context in which this is running. Snyk really helps across the whole SDLC. I'm going to focus mostly on container in this aspect. And, just from a standpoint of a container, so like imagine that you've got a container, like somewhere in the container, you're saying it's from another image. In this case, this container is from node 14. You can see exactly what you're saying. There's 1,000 vulnerabilities in this, and there's 49 of them are critical. So it's like, where do I start? Traditional tools, AppSec tools, they're going to tell you they're going to find the things. Some might find more, some might find less, depending on the context they're running. Maybe it isn't applicable for Ubuntu or something like that. In this case, they're going to tell you what kind of fix it's in. And like, this one there's 1.49 fixed in 10 and 11. But me as a developer, what do I do with this? Am I supposed to fix my Docker file? Am I supposed to patch these in? Even if I just fix that 49, I've completely redone this, and now I'm maintaining this image. And when a new version of the base image comes out, how do I port those over? Snyk actually takes a little different approach to these things. Rather than trying to tell you, here's what's wrong and here's the things that are different, we try to get rid of things, more in bulk. So, again, we're starting from this node 14. In this case, it's giving me some image update suggestions. In this case, it's saying, if you move to the 14.21, you're going to knock out 2/3 of the vulnerabilities right off the bat, and you're going to move to having zero critical. And then even more, if you kind of take a little twist, instead of staying in the standard distribution, you jump to the slim, you're actually going to cut that down by a tremendous amount. Math is hard. I'm not going to try percentages. Let me jump back to a little quick container setup in the way. It's like there's a couple different ways companies use containers or build containers. In some cases, the developers are the ones that are responsible for the whole thing. They're out there, they're choosing a base image, normally based off of the, like Node in that case, or the operating language they're using. They're adding common software and common configuration. So maybe they're adding things with apt-get, maybe they're adding curl like Victor did in his demo. And then finally, maybe they have like observability libraries they need to add, or logging libraries. And then they add their application. Now this includes the application and any like libraries that the package managers for that app are going to add. Other teams, they use this kind of split responsibility model. And this model, instead of the developer owning everything, they have a platform team that's responsible for the actual base images themselves. And then the developer only needs to worry about the application. In this case, they don't have to worry about the things in the base image and the vulnerabilities. They only care about what they add to the application. And then you have that same kind of workflow where you can find better base images, but within the context of what your company has or your team has given. I'm going to jump into a quick little demo. In this case, I'm looking at the Snyk UI, and I'm going to wear 2 different hats in the demo. I've got the platform team. The platform team is the one that's responsible for building these images. I built 3 different images, Node.js, .1, 2, and 3, and we can see that the most recent one is Node.js 3. I want to mark this as a custom base image, and when I do that and I drill down, I actually have the ability to look at it now. In the platform team, I have the same ability to use the recommendations for my base images, but in the setting standpoint, I can actually turn this on and call this a base image so that my developers can work. And now if I navigate over to my development team, I can see my projects. I've got my application here. I've got an application, and I have it configured so it knows where that Docker file is. And if I drill down to the Docker file, as the developer here with this developer hat on, I can see I have these same kind of things to my disposal. And I can see I've got my current image as a .1. .3 takes me to a minor upgrade, and it actually shows me I'm only down to, I'm cutting my vulnerabilities in half. I don't have much to do. I can actually just click the open fix PR and go in, and I don't have to go into my IDE or my CLI to change things. It actually opens a fix PR for me. And that way it helps us remediate and fix things right off the bat.
Too late.
I beat you.
He finished early.
I made it.
I don't have a gong. That's my loudest thing I could find. Maybe like a child, I could bang pot pans
Yes.
together. We got to take this off the screen. All right. Thank you so much for your presentation. That was fabulous. And we're getting a lot of questions, which is wonderful. And we'll answer those questions here at the end. So we see your questions and thank you. All right. Welcome. Let me reset the timer before I put you on the screen. All right. Here we go. And as soon as you start talking, I'll start your time.
Okay, so good evening here, morning everywhere else. I'd like to introduce Kubescape. We are a CNCF sandbox project, first and only CNCF Kubernetes scanner. So what has Kubescape always done? We talk about configuration scanning. This is what Victor kind of alluded to when he said the things that you shouldn't be doing. We started out with that. We have a huge library of 220 security controls that span different hardening and compliance frameworks. So that's what you should and shouldn't do. And then we've got the vulnerability scanning that we talked about, which is the CVEs, and it's spewing out the whole list of CVEs and what we should be looking at first. So we have that. We know what we implemented eBPF in order to increase the signal and reduce the noise. So this is a good place to start. But Kubescape has, like you said about the other project, has evolved. So we can look at Kubernetes infrastructure set up at the control plane, kubelet, or even at the cloud service provider API. We scan workload configurations for security context, the container image, best practices, and we can put these things in the CI/CD. We have created admission policy controls based on CEL, which came out in Kubernetes 1.27, if I'm not mistaken, but it's still in beta, and vulnerability scanning, of course. Kubescape is also the first and only project that can auto-generate VEX documents, which are really important, especially for open source projects, because it's a lot of manual work. And yet, on the other hand, this is something that it's consumed by people using your software to know that it's safe. And to kind of loop it into last week's episode, Kubescape can now even generate network policies based on application behavior in order to provide you with kind of good practices that won't break your application. So 2 ways to use Kubescape because there's the whole agentless and agent-based discussion. So you can run it agentless. And it's good for CI and it supports the whole shift left concept. And yet we know that when you look from the outside in, you don't get enough information. So we also have an agent, and you can do agent-based, and that's good for monitoring. And it brings in the power of eBPF because we can look into the kernel, and findings are stored in CRDs, and you keep them in the cluster so that you know what's going on. And we're pre-integrated with Prometheus Exporter in order to create alerts and actually know what's going on over time. So let's do sort of a demo because we're short on time. I will be showing you this GIF. So this is basically what Kubescape looks like when you're running it through the CLI. It initializes a scanner. It shows you the different concerns that you may have. And then it shows you the highest stake workloads so that you know where to continue from. Because that's the whole basic thing that Victor was saying, that security people bring bad news, but this is kind of lighting the path into how we solve these problems and what you should be looking at first. And I am done because, as I promised, I speak very quickly.
Absolutely amazing. Thank you so much. Let's get your screen off. I'm a little thankful I didn't have to lift that piano again. It's not light. So thank you. Let's bring Jamie on the screen. Thank you so much, everyone. We got a lot of great questions. Thank you all for your questions. Keep them coming. And we're going to dig right in. Let me scroll up. So you both are awesome. So how about
that? You don't have to say it. We know it.
This is a great question. What about alerting? Like if something's super duper important, like the Log4j or whatever, where it's time you need to like drop your fork while you're eating dinner and run to your computer, like what does each tool do as far as alerting goes? And then also, what does each tool, do you have any AI integrations? So let's start with you, Jamie, please.
All right, that's a pretty broad question, covers a lot of areas.
Okay.
And I have to mention that I don't know everything in depth, but from like an alerting standpoint, it's really important to know what applications you have. Like Victor deployed a couple pods, and if you don't know necessarily where the code's coming from and what you're running on a daily basis, because not all jobs run all the time. So having an index of your applications and your jobs, it's important, because when something new comes out, you're not having to go figure out what you're doing. So it's having that inventory, in whatever tool it is you're using. That's the first step. Now Snyk has the ability to tie into things like Slack or email and stuff. So if a new vulnerability comes out, it is going to send out a notification. AI, from an open source standpoint, Snyk doesn't currently have, other than some things in the back end. AI we use a bit more with the code, like the SAST solution for finding issues with first party code, the code you're writing.
Excellent. Thank you. Oshrat?
Okay, so as I mentioned, we have a pre-integration with Prometheus Exporter, which you can then push to your Grafana or through Prometheus to your alert manager, and get that information. Of course, configurable, get what you want. Armo's commercial solution, of course, has a finer and more larger ways to communicate these things. But if we're talking open source in Kubescape, this is what we have. And as for AI, we played around with that for a bit in order to write security controls using ChatGPT. That was a little over a year ago, still not mature enough in order to write Rego at the level that a human being that knows Rego can write. So for now, our security controls are written by humans, either in Rego or in CL.
Amazing. We have another great question. This is for both of you. We'll start with Oshrat first. Do you believe a single scanner is enough, or should we aim to use multiple scanners? It seems that no two scanners give the same results on images. Everyone finds other vulnerabilities and miss some. Oshrat, you go first, please.
There's only one scanner to use. It's Kubescape. It's pretty clear,
yeah,
right?
Sure. Uh-huh.
But what I can say is that Kubescape looks at multiple databases. You were talking about NVD earlier, Whitney. So yeah, we look at different databases, NVD. And we even apply different different sorts of scoring, and we sort of create a risk score, which is something that we created in order to kind of take away that very, very specific language of each scanner and each database, and make it holistic, because you shouldn't care where the information comes from. You should care that it's complete and it's useful. So yeah, that's how we do it.
Excellent. And how about you, Jamie?
I would say that, from a scanning standpoint, it's one is sufficient. I'm not going to say which it is, but but like the difference is, you'll run things and you'll see things, and like when you get involved in like a what's it called, head-to-head combat, and some of these deals and things, you hear, and that's one of the things you have to justify, and you're going to find different things. One aspect is like, when you're running something, when Snyk is putting a vulnerability score out there, it's taking it into consideration. We saw in the screenshot that runtime context, but it's also looking at things like, this really only impacts this library when it's running on Windows. It doesn't impact it when it's running on Ubuntu, and you're running on Ubuntu, so it's not nearly as important. So something to take into consideration. Like when you're evaluating things, it's always good to like compare them on your workload and try to, don't just look at the differences, because you got to look at the commonalities, because they might pull out the same thing, and one might say it's a 10, one might say it's a 2. Kind of do that comparison and try to figure out which works better for you, and take into consideration the impact, and do a deep dive on the differences. It's always good to compare and contrast.
Excellent. Thank you. And so the next question we have, because of the nature of this show, we have a bunch of Snyk questions and then Kubescape's questions. So I'm going to try to bounce back and forth a little bit. But one thing I want to know, or the people want to know, is can Snyk do Kubernetes scanning, like configuration scanning, similar to what Kubescape does? Or what does Snyk do, I guess? Let's make it more general with Kubernetes specifically.
Kubernetes, since Kubernetes, Snyk has, at the beginning I skipped through because I had 5 minutes. We actually have an infrastructure as code piece that actually has some cloud context awareness. I'm not an expert in it, but they do have Kubernetes scanning, and I can probably tie in more answers, but to the other one that's down there, but I'll wait for it. So we do have some scanning of infrastructure as code, to try to find, like Victor had mentioned, misconfigurations in your environment, things like that.
Okay, excellent, cool. And then, and it can work with CRDs. Do you know? It's going to work with custom resources?
I don't know. I'm not going to say no, but I don't know.
Okay, excellent. We do have a You Choose channel on the CNCF workspace. So if we want to take any of this stuff, if you want to look some stuff up and get back to us, you're welcome to do that there. But you also don't have to. Well, you do you. Let's ask... Sorry, it's hard for me to jump back and forth. So I'm just going to go in order if you don't mind. How does Snyk have support for checking Helm files that are in the repository?
So sorry for interrupting, but kind of basically many of those questions have Snyk or Kubescape.
Yeah, this one
but they're actually generic and
apply
can be
to both.
To either, yeah.
Yeah, I agree with that. So let's Oshrat, why don't you answer this one in terms of Helm files, scanning Helm files, and in general infrastructure as code scanning?
So yeah, it's supported. We can support Helm. We support scanning customize. So yeah, you may remember on one of the slides, and maybe I'll post it to the deck to the YouTube to the You Choose channel. Yeah. But we do scan it at many different levels. So yes, the Helm, and we do repository scanning and registry scanning, apart from, because those are 2 scans that you forgot, Victor, when you were talking about scans.
I forgot more than 2. I can
So and yes, that is covered. Yeah.
Okay, and while I have you, might as well. How about security policies for Kubernetes and CRDs for Kubernetes that were asked in the last question related to Kubescape?
So again, security policies within the configuration scanning of the whole doing what's right sort of thing, in order to kind of bring us to zero trust and least privilege. That's where kind of the guidance takes you. I must add here the idea of context, which is doing it without breaking the applications running on the infrastructure, because the most simplistic example that I always give is many of the frameworks say you should not be connected to the internet because that, of course, makes you a target for malicious actors. And yet, in order for eShop, for instance, to work, it has to be connected to the internet. So you don't want to close that one off, even though it is considered a misconfiguration according to a benchmark. So yeah, that's something we do. And in terms of CRDs, I know that the results are saved in CRDs. I don't know if and how we scan CRDs, but I can check.
Okay, excellent. And then, Jamie, you kind of talked about infrastructure as code scanning, and that's not your forte, but do you know about Helm files? How Snyk works with Helm files?
So they don't scan them directly, but if you convert them into convert it to a Kubernetes manifest, you can scan those.
Okay, awesome. We'll start with Snyk this time. Does Snyk have any understanding of build pack builds instead of Dockerfile or BuildKit based builds?
No, at this point, it's Dockerfile based. They're looking to expand that, but it's not that on the roadmap that I know of.
Okay, excellent. And Oshrat, can you speak to the same in Kubescape?
I actually do not know.
All right, that's a respectable answer. That answer gives credibility in my book. Does Snyk plan to be able to create your own policies for testing infrastructure as code files?
They actually have custom. I looked this up. They do support custom rules, but the custom rules are part of the enterprise plan.
Okay. And can Kubescape create your own policies for infrastructure scanning, configuration scanning?
Of course, there's the KubeVol library. If I'm not mistaken, I need to check the repo. But there is a library of controls where it's an open source project. You want to add a custom control, write a rego, create a pull request. We'll test it. We'll put it in, and we'll thank you.
Excellent. And flower petals will fall from the sky slowly. Victor, what is Wolfie, please?
Wolfie is the base image you should be using when you cannot use Scratch image.
Okay, so that's Wolfie's a base image for containers, yeah?
So exactly, base image. Now, ideally, your image, not the base image, should have nothing but your code, your application, right? Nothing. That would be Scratch. Scratch is nothing. Now, for some applications, that doesn't work. Something is required. And
like
then
what?
You have like glibc, for example.
Okay.
Right. Some kind of library, something that your application needs to work properly might be required. Or if you're using Java, for example, JDK is required. Now, you have two options to do it. You can think of container images as virtual machines, and you say, I'm going to put the whole operating system. I'm going to put Ubuntu as a base image, right? Or you can go with the bare minimum that is more than nothing, right? And that would be Alpine or Wolfie. Wolfie is awesome. This is now shout out to Chainguard, right? Wolfie is awesome because it's like Alpine. It's minimalistic. It's only what you need, but it's built and scanned daily or even more frequently than that, right? So short answer is yes.
And
I love Wolfie.
How does that relate to the scanning projects? Like Oshrat, how does that relate to you? Do you know? Oh, wait, Victor seems like he wants to say.
No, important thing, and I don't know what you guys think, is kind of the less you have of what you don't need, the better you are, right? And you are going to get results of vulnerabilities that truly affect you. Instead of when you say, oh, I'm going to download whole internet. And put it as a base image and then ask Kubescape or Snyk, can you tell me what are vulnerabilities? Then we're not talking about 1,000 anymore. We're talking about 10,000, right? Sorry, I hijacked.
You lit up. I like it. No, I was fascinated. I had never heard of Wolfie before right now. And so, like, ideally, that's going to make your jobs as scanners easier, right?
Well, not our jobs. Scanners don't care. It's code. Yeah. But the people that get the results, it will solve their CVE shock problem because there will be less CVEs to look at in the output. And
important ones.
In terms of what a Kubescape does, and I think I understood that Snyk does too, is you won't have the same number of vulnerabilities that are not in context, that are kind of not in memory, not in context, or whatever. You'll just have like the gross and the net will be the same or close to the same number.
That's great. Is there anything you'd like to add, Jamie?
Yeah, so one aspect of it is, the Wolfie images can still get vulnerabilities. They build them, they don't have vulnerabilities. Just like when you get an SBOM that has vulnerability information in it, that's a point in time. When there's a new 0-day discovered, that could be lurking in these things. And even when, Wolfie, they've been like, I know there were a couple recently that they had them for like a brief window of time. When they fix their base image, that's one thing. They use kind of a rolling label, rolling tag or whatever. And just because they fixed it doesn't mean that you're safe now. You've still got to rebuild and redeploy. So, that's the kind of thing, back to one of the questions about notifications, that this is broken, go fix it and rebuild it and go from there.
That's a great point.
I feel that that's a problem that many people are having or misunderstand it. Okay, I scan my stuff, I'm safe.
Right.
Which from my understanding is that, you might have been, maybe you were safe at the time you scanned it. And I was like, maybe. And a minute later, not anymore. Type of.
Exactly.
And even when you find the vulnerabilities, then you found them, yay. You've prioritized them, great. But now there's a whole bunch of work, and I'm talking about weeks and months of work in order to patch, test, roll out, deploy, and then you have to rescan it because it's in production and things can change.
Okay, I'm getting a picture of why Victor told me at the very, very beginning of all this, why security can be a pain. Yeah. Can we get to my question?
So it's the pain to go to the dentist, yet you still need to do it.
But if we're using that analogy, regular scanning is like getting your teeth cleaned.
It's preventative.
Have to deal with small things rather than the root canal.
Yeah, that's great. So my question from earlier, when Victor and I were just chit-chatting up top, was when you're talking about everything that's getting scanned, all the different images, running workloads, all the configuration, that seems like an awful lot of access you're giving to one tool to like touch everything in your system. Can you talk to me about how that works? Like, how is that safe? Oshrat, do you want to go first this time?
So firstly, with Kubescape, there's the option of going agentless, even though we don't recommend that because the things that you see from the outside or the things that you see from the inside aren't necessarily the things that you can access from the outside. So it's sort of it's a risk-benefit sort of decision.
Okay.
And that's why you need an impeccable reputation, and that's why we get all kinds of certifications like SOC 2 or ISO 27001. All of these things that are mechanisms that their purpose is to build trust.
Okay. Do you have anything to add, Jamie?
I'll echo that, except from the agentless standpoint. What we were looking at my case was like the Kubernetes thing. If that's not running, you still have a lot of the same insights into your environment. But you're right. You're giving somebody access to your infrastructure. You're giving them some sort of like IAM tokens and access to see your environment, your ecosystem. So you got to make sure that you're not just going. There is some level of trust. Just like there's some level of trust when you're using open source libraries. You got to start somewhere. And, it's a fragile chain of trust, but you've got to.
You look trustworthy, Jamie. I trust you. So this question is I think asking like, how difficult, what's the setup process, the install to be able to scan infrastructure? And Jamie, we'll start with you this time, please.
It's a similar thing. So if you're looking at you're installing some sort of agent or agent list in your cloud environment, give them access to it. And in Snyk IAC standpoint, from that standpoint, there's two parts, because you've got your IAC configuration in a Git repo or something somewhere, But then you've got your cloud infrastructure. So, your cloud infrastructure, you might have an environment variable. You have something set up that says, hey, this is exposed and it's not supposed to be based on what's in the IAC config. And, that's that, you get something like that. There's, people change stuff and you figure out I've drifted from what my IAC is. So, you're having both sides. This ties back to the previous question. You've got both things in both things being looked at, I should say.
Okay.
Usually, you're setting up a user or account on your cloud infrastructure or whatever to.
Okay. And how about for Kubescape?
First of all, Kubescape kind of looks at Kubernetes and not much beyond, even though we did see that we do a little bit with the cloud service provider and things to that effect. Again, can scan agentless. You can install the Helm chart on your. You can install the operator via the Helm chart on your cluster, and then go with what's there. But it's a simple curl if you're doing agentless, and it's a Helm install if you're not.
Excellent. Have there been vulnerabilities in eBPF itself? That's a fun question. Do you know anything about that? I don't. Yeah. That it does get back to like everything's built on everything else yeah.
Because there could be vulnerabilities in eBPF, but you could write a vulnerable rule, a rule that takes advantage of things that.
Exactly. It's my understanding is not that much about eBPF itself, but about applications that are based on eBPF, right? So Cilium itself might be vulnerable, right?
Okay. That makes sense. What SBOM formats?
Or malicious. That's more dangerous, kind of like not necessarily vulnerability, but if you use somebody's solution as eBPF, you're giving that somebody something access at a deeper level than many other things. Not necessarily is a bad thing, but
it's something to be aware of for sure. Yeah. What SBOM formats do you support? Shrat.
I actually don't know. I know what Vex format we support, but I do not know what SBOM format we support.
Okay, I don't even know what they are. I mean, I know what SBOMs are, but I don't know the
I didn't know
possible
that
formats. Yeah.
I would assume it's probably similar to what we do. It's CycloneDX and SPDX are the two that are the most.
So we've recently migrated to SPDX.
Okay. And then where should images be scanned? In CI, in the registry, or at runtime? I have a guess. Is the answer all three?
Can I?
Yeah. It's a good point to make, though, for sure. It's
Yes, and more than once.
Yeah.
Continuously.
Because those are very different things, right? One thing is to scan stuff before it becomes reality. Right?
Yeah.
That would be probably CI or whatever, before it becomes a thing. And the other thing is that scanning whether this thing that is a thing is now vulnerable, right? Sorry, that's my amateur interpretation of it, right?
Yeah. What tool do you know that will allow you to scale Helm files when creating a pull request? I like to check. Oh, so like almost a pre-scan before it actually even gets put anywhere?
I feel that we already answered that one, right?
Okay.
Maybe I'm
Check my files for policies when creating a PR, and those PRs past the scan can be merged. So we did talk about scanning Helm charts, and both tools do that. And
so if we're at the very beginning of the software development lifecycle, scan the Helm chart, you can scan the repo with Kubescape, and you can scan registries. So that's kind of the very, very starting point. That's kind of
excellent. And Jamie, in terms of like the early part of the software developer lifecycle, where does Snyk fit into that?
Okay, so Snyk.
Sorry.
Oh, sorry. Like that. My little caveat of you'd have to have a process that it blows it out into a Kubernetes manifest, and you could then check those in like a CI/CD pipeline. I don't know. I'll have to look it up and see if we have PR. There's a difference between checking in a CI/CD pipeline versus a PR check, which you know, auto magic. So, and I don't think we have. I don't know if we have PR checks for IAC.
Mm-hmm. Everyone who's asking all these wonderful questions, if we don't answer in a way that makes you happy, you're welcome to ask again in the You Choose channel, and we'll see if we can find more deeper answer for you. Does Snyk plan to support SBOM output for non-enterprise accounts?
Unfortunately, the way it's implemented, it actually leverages, it was an API first thing, and our API is limited to the enterprise plan.
All right.
So unfortunately, no.
And do you want to say something about your SBOM output for Kubescape?
It's open source. Feel free to use it.
Right on. Does Snyk intend to support Pulumi in the future?
I don't even know what that is. Can I have a hint?
It's
can
like
I phone it up?
Terraform. But
It's
like Terraform, but different.
Yeah, infrastructure is code, but using whatever language you want.
Yeah, I think I'm going to say I'm going to plead the fifth and say I don't know.
Okay.
I'll have to look that one up as well.
Excellent. Does Snyk intend to add infrastructure as code scanning for crossplane? Oh, Victor.
Can we say IBID?
So crossplane would give you CRDs, and you already said you're not sure about.
Yeah, I'm not sure.
I think infrastructure as code CRDs. So the answer is I don't know. And this is our last question. Any more questions come in, we're going to put them in the channel. So a huge percentage of time of a scan is the analysis of the image. Does Kubescape or Snyk support scanning based on an SBOM like Gripe and Anchor does as a way to speed up scanning?
Yes. Well, Kubescape creates SBOMs in order to run the scan, and we actually use Gripe under the hood, if I'm not mistaken.
I've heard the same.
Yeah, and another thing that I'd like to add is based on the SBOM created by Kubescape, you can create a VEX document. Which can be consumed by applications such as Gripe or Trivy, for instance. And that's very, very helpful because it's sort of something that you give with your software in order to be scanned so that people know what's in there. Sort of part of as a continuation of the thought of the SBOM. The problem with VEX documents is that they change all the time, and it's a lot of manual work to create them. So the fact that they can be auto-generated is a very, very big plus when you are creating software open source, which is short in contributors all the time. So this automation is very helpful.
Excellent. And how about for you, Jamie?
We don't use SBOMs because like when we wrote Snyk container, SBOM wasn't even a term yet, but internally it is basically building a dependency graph and using that dependency graph to do those things. I liked what you said about them getting out of date. Snyk does have, if you haven't played with it, Snyk has an open source thing. It's called Parlay, and it actually takes an SBOM. I don't know if they switched it to support SPDX and CycloneDX. But it can go and take any given SBOM and enrich it with vulnerability information, or like licensing stuff. It uses ecosystems as a backend for licensing, and of course, it uses Snyk from the vulnerability side.
Excellent. There are more questions coming in. Should we just take them? Is that okay with you? Yeah.
Let's close it.
If we can answer them.
Okay.
You want to? Okay, we'll do these two, and then we're really going to close it for real. So we'll put your questions in the You Choose chat. So it says Snyk's official scanner images run as root. I don't really know the term of the shoemaker going barefoot, but can you speak to the scanner running as root?
Actually, I didn't know that. I run it as me, but I'm in the Docker group, so I don't know that that's necessarily accurate, but
okay,
it's it's in the same kind of realm of there's some level of trust when you're running some of these things.
It does seem to need access to everything. If it's going to make sure it's all good. Yeah. It's,
This is now more philosophical, not related to any of those tools. But the less access you give, you're safer from that perspective, but then less things the tools can tell you, right? So it's kind of, if you want a tool to give you all the information, then you need to give it all the access. In a way, I might be wrong, but sounds logical to me.
Yeah. So, what in the case of an air gap system, how would each scanning tool fit into the workflow there? So we'll start with you, Jamie.
That's tricky. I don't know. I haven't worked with, like when you sit, I know that you can set up policies to do this, but those policies, again, it's going against your Snyk interface, which is generally in the cloud somewhere.
So it probably gets scanned while it has the internet access and then goes in, but then it can't be continuously scanned without.
Yeah, I mean, to me, that's more of that's a runtime and deployment aspect. And like Snyk doesn't have like an admissions controller or anything like that. And that kind of sounds like that's where that would be coming from.
And it's never really air gapped 100%, right?
True.
Yeah.
You're going to use a base. You're likely not building your own base images, right? You're likely getting stuff from somewhere, even if you're air gapped, right? It must come from somewhere, unless you are writing your own from scratch everything, right?
Yeah. Now, if we take it with that kind of direction, Snyk supports, what's it called? Private label registries, so you can actually have your own registries, and your deployments, if you're using custom-based image recommendations or custom-based images, you can make sure that these are being pulled in from your registry, and again, using the similar tools that Kubescape uses in the back end, like Rego and policy, but that's going to be something that you're going to kind of manually set up within your CI/CD pipelines to make sure you're not pulling something outside of your realm.
Excellent. And what's Kubescape's take on air gap?
Install it in your air gapped environment and you've got it.
Yeah. All right. Cool. That's a wrap. We're going to have you each say a closing statement, a couple sentences about why everyone should vote for your tool. So Jamie, we'll have you go first.
I'll go first, and I'm going to take a quick detour, and I'm going to go back to something that Victor said.
Okay.
Just do something. Pick something. Don't just not do any. Don't do nothing. From a Snyk standpoint, our differentiator is we don't just help you find stuff. We actually help you through walk developers that don't really want to know stuff about security. We help them fix issues.
That's brilliant. That's great. Thank you so much, Jamie. Appreciate you sharing your time and expertise with us. Thank you. And your final statement, please, Oshrat.
Okay, Kubescape started as a scanner, vulnerability and configuration, and we're very good at that. It's now growing more to the right, and we'll be seeing more developments around runtime security as well. The idea is to bring the CNCF a end-to-end Kubernetes security solution, and that's where Kubescape is headed. I just want to add a plug. We're doing a bid for incubation this year. So if you're using Kubescape and you're happy with Kubescape, please add yourself to the adopters MD on the Kubescape repo. And
excellent. Thank you so much. Appreciate you.
Thank you. It was fun. Bye.
Bye. And then there were two. It is time, friends, to vote. Thank you for all of your wonderful questions and being so engaged. This is the most beautiful link. Maybe we can put it into the chat too, so it's clickable. It's also in the description of this video, so you can go click it there.
And I'll put it to chat right away. But yeah, it's in the description. I'm not even sure whether chat is maintained after we stop going.
I believe
being
so.
Live. Maybe. Okay. Then yes. Yes. The answer is yes. Because I trust Whitney. Anyways, there's a link. You will never be able to type it because it's silly, but it's in the description, in the comments, everywhere.
So it's going to take you to the
I mean,
CNCF
even
Slack
if you don't
workspace.
find the link, it's in CNCF. You should be there anyways, and then you can find it.
Yes. It's you choose, you dash choose. And I think that's a wrap. We also have, if you want to work through these on your own, there's a CNCF demo repo that you can, it's also in the description. If you want to choose your own adventure, if you don't like the choices that your peers have made so far, you can do it yourself, just like Victor does every week. He made it, so
Exactly.
well,
Except
we both did.
You saw me doing it instead of me cheating on a second monitor. Yes.
Exactly. So please join us next week. Next week, we're going to talk about signing. We'll have Sigstore and Notary and open policy containers on next week. And that's a wrap. Thank you so much, everyone. Have a wonderful rest of your Tuesday.
Cheers, everyone.